Hi, this is Mrs. Pullen again. This is day 2 of Unit 3, and we're going to look at zeros, minima and maxima, and hugs and kisses. We're going to start off with a warm-up, so please put the video on hold and try your hand at this. Okay, hopefully you did the following. We see there are four terms, so we'd like to see if we can solve this using the factoring technique of grouping. So I pair off the first two terms and the second two terms. I factor out a GCF of x squared from the first two. And from the second two, I'm going to factor out -5. I now see a common factor of 3x plus 1. That's my GCF. And I'm left with x squared minus 5. I set each linear factor equal to 0 and solve. So one solution is x is equal to -3. For the second factor, this is an incomplete quadratic equation, so I add 5 to both sides. And when I take a square root, I end up with both a positive and negative value. You should put your final answer in solution set. And hopefully you arrived at this answer. Zeros are the point where the polynomial intersects the x-axis. So we have it intersecting or touching here, here, and it passes through here. And we're going to get into in a little bit what it means when it just touches the x-axis. The reason why they're called zero is because they're actually touching the x-axis, and the equation of the x-axis is y is equal to 0. A polynomial function of degree n has at most n real zeros. So if I have a function that is, let's say, x to the 7th, that means there are at most 7 zeros, real zeros. We're going to get into non-real zeros in a couple of units from now. Okay, so I want to now talk to you about what it means for a function to be increasing and decreasing. And if we just take a look at the other slide, a function is increasing if as you increase your x, let me get a pen out. So as x increases, so as you go to the right, your y value or f of x increases, it's going up. If a function is decreasing over an interval, if as you go to the right, your y values are actually going down. A function is constant over an interval if as you increase your x value, your y remains the same. So it's basically a horizontal line. When we're looking to see if a function is increasing or decreasing or staying constant, we define it over our x interval. So let's take a look here. As I start reading from this point, I'm going up as my x values, and I'm going up until I hit that value -3. So we could see that the function is increasing from -infinity to -3. There's another place that it's increasing. If we take a look here, do you see how it's going up from 1 until 4? So we say it's also increasing, the function's increasing from 1 to 4. The function is decreasing, let me get a different color pen out, from -3. Do you see how it's going downhill? So we say it's decreasing from -3 until 1. And finally, the very last spot that it's it's remaining constant, and you could see here, it's staying the same right over there. And so that is from 4 to positive infinity. What I'd like you to do is put the video on hold, and I'd like you to try example 2, which is a graph of this function f of x shown below. I want you to decide for what values of x is the function strictly decreasing and strictly increasing. So please put it on hold. Okay, we're back, and we could see that the function is increasing until you get to that point, and that point looks like it's -4, and that looks like 28. So, and we can see that the function is decreasing. I'm going to make little green negative signs from -4 until that looks like 2, comma -8. And then it starts increasing again from that point. So again, the function is increasing from -infinity to -4, and from 2 to infinity, and it's decreasing from -4 until 2. Relative maxima and minima. A polynomial function of degree n has at most n-1 terms, so that's really important. Let's get something out to highlight that. Sorry about that. So I highlighted there are n-1 terms, whatever the degree is -1. And basically what these points are is where the graph changes direction. So we can see that over here, our function is increasing and then decreasing. So this point over here is a relative maxima. And here you're going from decreasing to increasing. So that's considered a relative minima. Their turns. So I have 1, 2 maxima and 1, 2 minima. So for the following functions, I'd like you to determine the degree of the polynomial, as well as the x-intercepts and the number of relative minima maxima. So to get the degree, we would just go ahead and multiply the x's, and actually we can see that we have x times x times x for that first term. That's x cubed. That means the degree of the function is 3. We can see that there are 1, 2, 3, so that it actually equals to the degree. And we can see we have 1, that's a relative maxima. And here's a relative minima. So we have 2, and that matches that formula of n-1. For part B, we have x times x times x times x, or x to the 4th. So the degree is 4. I have 1, 2, 3, 4 x-intercepts, and the number of turns is 1, 2, 3, and that 2 matches that formula of n-1. What I'd like you to do right now is put the video on hold and work on part C and D. Okay, take a look at the results and see if you matched the answers. Here, even though I have a degree of 2, notice there's the degree of 2. Notice that the function does not intersect the x-axis at all, so it has 0 x-intercepts, yet it has 1 minima. Notice that there's a change of the direction, so here's that minimum point. For part D, x squared times x is x cubed, so we have a degree of 3. We see that it intersects the x-axis in one spot, and there's no change in direction, right? So there's actually no minima or maxima here. In any case, this is the first half of today's lesson. I'm going to make a second video on this lesson, so expect to see that in a few minutes.